All right. Welcome, everybody. Thanks for coming in, sitting in on my talk about remotely exploiting connected vehicle APIs and applications. So first, my name is Aaron Guzman. Twitter handle is up there as Scripting XSS. First things first, I love pizza this trip. I've been here since Tuesday. I had pizza 3 times already. Each different places, of course. But everywhere I go, everywhere I travel, pizza is definitely on the list. I'm from Los Angeles. I'm a co-organizer of AppSec California, which is an OWASP conference in Los Angeles and Santa Monica on the beach last week of January. If any of you guys want to get away from the cold and rainy, cloudy weather, I manage the volunteers and get you in for free. I hack all the things. Literally, I used to work at Balkan and Linksys, so that's kind of how I got wrapped up in embedded and IoT. I used to lead security for the networking aspects, so that's like the routers and the cameras as well. I was a technical editor for Practical Internet of Things book that came out last year, and the second revision just came out actually. I'm currently writing a book for pen testing IoT cookbook for Packet Publishing as well, finishing the last chapter, so that should be out maybe in the next month or so. I'm a board member for OWASP Los Angeles, as well as Cloud Security Alliance Southern California. And I contribute to a lot of white papers. My current employer is GDS, Gotham Digital Science. So today's topic, while you guys are all here, I'm going to be talking about Subaru Starlink remote services. And specifically, that is the in-vehicle technology and the capabilities that Subaru has introduced into their cars from some 2016 models and all 2017 moving forward. And what you can do is you can unlock, lock your vehicle, you can honk the horn, you can locate, you can have a vehicle health report, you can schedule any services, you can see personal information, VIN number, addresses, and then we'll go into the details afterwards as far as the exact data that is captured with Subaru Starlink. What it doesn't have, though, is a remote start feature. So it's purely just unlock, lock, honk the horn. But I mean, someone could really just purchase an add-on. It's only 300 and something US to install remote engine start. And I'm pretty sure there's a capability to remotely use that as in the application. So, it might be introduced in the future, but just to kind of set the stage, it is only unlock, lock, locate the vehicle, as well as the owner. So again, I mentioned only a certain number of vehicles are supported for Starlink. Anybody have a Subaru by chance? Show of hands. Oh, wow. That's good, I guess. All right, so like I said, there's mostly 2017 and 18 moving forward, but there's also some 2016 models. And because, I mean, for that exact reason, I asked you guys how many, how many of you guys have a Subaru? No hands. So literally, I purchased the vehicle to perform research on it. And I had a 2016 version thinking that it was going to be connected, but it didn't have telematics. So literally, I waited till my lease, 6 months, got to 2017, and we'll go through the timeline afterwards. But it's a fun story. But along with the motivations was that DMCA for the U.S. They're exempt for anything IoT or consumer products, so you can now test security research as long as it's lawfully acquired, as long as you have good faith, it's in a controlled environment. So it's totally fair game now, which is cool. And definitely, I have an Impreza STI, so it's a fun car for sure. But I didn't want a Leaf or a Prius. And not only that, I mean, research's been done on that by you guys already know from years already. And again, when I had my 2016 version, it did have capabilities to log in and manage my car, just the services, like just schedule a service with like a sales branch office of Subaru. But nothing crazy. So I'm going to jump right in and show you guys exactly what I found. Then I'll go through the methodology in which I found it. I'll kind of go the opposite way typically. So here we go. I figured, might as well be cliche. I'm from Los Angeles. Might as well, film it at Santa Monica.
Hello, everyone. Today we will be demonstrating remote exploitation of Subaru Starlink remote services to unlock, lock the vehicle, add 2 users to the account, which has full control over a Subaru account. Also view usage report, but what I'm going to demonstrate today is just adding 2 users, unlocking the vehicle, honking the horn, and flashing the lights. So first, what we'll get started is making sure the vehicle is locked by pressing the lock button twice here. So
Just want to stop and just say this is the exact video I sent to Subaru. So and there's also other videos following up, but just to let you know, it's the exact video.
honks. And then we'll place the keys here on top. And we'll first show you that there are no authorized users to a Subaru account here. Let's refresh. Refreshing.
The vehicle is always connected. It's connected via 4G, AT&T via ISP. So what I'm doing is tethering to an iPhone. So I can,
Authorized
make
users.
these calls remotely.
So let's go
My
ahead
car's in
and
total
run our
separate
script here. We already have a previous one, but let's go ahead and run it again. Just to show we're bypassing authorization. The vehicle is going to unlock. The horn is going to honk. Keep an eye on the keys on top of the roof.
Fast forward.
Okay. Car is now unlocked. And the horn will now honk. The lights will now flash. Okay. So now that we know the car is unlocked, horn is honking, let's make sure the car is unlocked. Let's check out. Car is unlocked, full access. And then let's check the users that have been added to the My Subaru account. And again, keys are up here. And remember, we did lock the car. So refreshing the screen over here for the My Subaru account, you can now see 2 users have been added. Awesome. And again, these 2 users have full access to My Subaru account to view everything as if you were the owner and not a subset. So that's also something to keep in mind. So again, works 100% of the time, remotely unlocking the vehicle. You saw the keys were on the roof here, and we unlocked the car, honked the horn, and flashed the lights. Again, this is a Subaru WRX STI, 2017.
So here's how it looks when you're adding the users, authorized users. So again, authorized users have the same access as if you were the owner. So I'll discuss the steps in which, how the script is created and the vulnerabilities and such. So I'm gonna go ahead and run my script here. So the infrastructure in which Subaru runs, it runs, like I said, 4G, AT&T, but then it also goes through Amazon AWS. So it takes some time, loops back around. I even tried this. I found it right before RSA in San Francisco. I even tried it on the airplane, and it worked. I wanted to make sure it worked all the time. So these are 2 emails: car hacking email at Gmail, car hacking email 1 at Gmail. So I should flip back over to the Subaru page, refresh. Now we have 2 users. And they don't even have to have a Subaru or My Subaru account. It just sends an email, and they create an account. So you can literally just kind of make up email addresses. And again, I'll go through some of the other vulnerabilities that were observed. So there we have it. Now let's swap back over here. So it's pretty simple, actually. There's nothing groundbreaking. You'll see why. You know, and this is what one of my buddies coined, World Remote Executable, WRX, STI. There were some articles written about this when I released it back in June, and it kind of influenced the new applications being built for Subaru, so now they totally rebuilt it. But here's like the timeline in which I purchased the vehicle late January. Actually got delivered to my house a couple days later. I pinged my buddy Sammy Camcar. If you guys know Sammy, he's hilarious. So he lives kind of close by. And I was like, hey, dude, I got this new connected vehicle. You know, let's start hacking. He goes, yeah, man, do you have any PCAPs? Do you have any burp state files, anything? And literally, you know, within, you know, an hour, you can see 726, 856. I wrote him back. I was like, actually, dude, it's pretty simple to do from the mobile and web app. I gotta get this out of the way. Found an auth bypass, session fixation, XSS, and a way to add a user to my account who can also unlock my car. Going to script it up. And he was like, oh, awesome, man. So then I created a video on the 2nd of February. But I felt it wasn't of good quality. It was like in a park, and I needed to be, again, cliche, go to Santa Monica because I live in Los Angeles. So recorded the video we just saw. I disclosed to Subaru the findings. Subaru acknowledged the findings after, you know, heckling around, finding who's the correct person to speak to. I got an update from Subaru a month later that they fixed the critical vulnerabilities that I discovered, like auth bypass is one of them, session fixation. And then they deployed new My Subaru apps for iOS and Android. And again, not the web app yet. So then I was in touch with a journalist over in Australia. I was doing a separate embedded talk. And that's, you know, kind of how the articles got written. But he had gotten in contact with their communications, you know, and legal counsel. And it kind of sparked a fire and some drama, stirred things up. So it turns out, you know, when it was published, the new web application also was revamped and deployed, which is totally different. And again, same thing with the My Subaru app for Android and iOS. And now, again, I'll talk about, you know, what these apps are, you know, what they consist of, and as far as, you know, libraries and the steps I took to kind of disassemble the applications. But they were pretty easy to work with. They gave me some credit, you know, giving details on how to fix things. They weren't too bad. They're, you know, open to research and open to, you know, finding, you know, to the community, basically. So again, how I got started, the first thing I always do, I'll perform a threat model, whether it's in my head, whether I'm writing it down. And I already knew there's, you know, connected vehicles, there's, you know, Bluetooth, again, 4G, LTE, the RF from the key fobs. There's, you know, SD cards that get plugged into the infotainment system. There's tuning applications and accessories like Cobb. There's, you know, the ECU. There's also, you know, OBD2 and CAN bus. But again, I knew there was Android app, iOS app, and a web app. And again, connected vehicles are the same thing as IoT. Very, very simple. You find the weakest link in the chain. But, you know, so for me, I'm an AppSec pen tester. So I'm going to go, you know, the easiest route, which is AppSec and mobile apps. And especially mobile apps, the first thing you're going to start, you know, it's probably Android or iOS. But, you know, again, IoT is so easy. Connected vehicles, it's the same thing. There's so many, again, attack surfaces. And, you know, hard work sucks, right? Why go for something difficult, have to be physically there when I can, you know, do it in my office and not have to be next to my car sitting down there sweating. So again, first thing, Android, of course, because Android's the easiest to kind of disassemble in the apps, and there's so many tools, literally can do it in a matter of seconds, can disassemble the APK and analyze the classes, the methods, monitor activities, services, and intent. So my goal was to almost statically analyze their code and find vulnerabilities in their logic and any vulnerable libraries and dependencies that they were using. And mind you, I did, like I said, last year, I had researched their apps before I had any like telemetry in my car or telematic system in my car. So I had an idea already, you know, what the app consists of, but they did change some things. However, I did look at the findings that I sent last year, which was a hard-coded client ID and secret for OAuth 2. which is not good. You can basically authenticate without putting a username or password. Similar to what I found, but we'll get to that in a bit. So I found it's a hybrid app. A hybrid app meaning it's most basically a web application and a mobile app, So it's not a native application. And then what I did, is perform recon and just, all the application functions. I did, all the login, log out, unlock, lock, honk the horn, flash lights, locate the vehicle, owner, view health reports. And this is all through, I did it through Burp and Zap as well. Anybody use Zap? No one ever uses Zap. Okay, we got one loyal user. Yeah. So I basically had a baseline. I highlighted things, commented to just get an idea what I can attack first. So next step was to set up the iOS infrastructure and proxying as well. And first, again, I start statically, right? I get the application, decrypt it, I drop it in Hopper so I can look at the code, statically analyze the code. So it's a little tiny bit more work than Android, but again, it's the same steps. You're going to dump the classes and the methods, look for anything that's hard-coded, anything that may be vulnerable. I look at the runtime behavior, when the app is running. And then I also had some findings from last year, which is they had a handoff token that was in the URL, not resolved, and we'll get to that in a bit. They also cached all requests and responses and put it in a cache database on the iOS device. So like literally everything, like your PII data, your passwords, your tokens, everything is cached. So they kind of fixed it though. They picked and chose what they were going to cache, but it still had sensitive data. So again, I'm going to analyze the storage on disk, whether that be plist files, SQLite databases, local storage files, and ROM databases. And then I went to the same approach, proxied all API calls from the mobile app. Log in, log out, lock, unlock, honk the horn, flash lights, locate the vehicle and owner, and then view the health report. And the health report just says, if all systems are good, it tells you the mileage, it tells you if there's any issues. It gives you literally the usage report of how many times you've unlocked your car, locked it, how many times you used to locate. So it gives you, pretty granular details, usage data, which could be used, privacy-wise. And you could also edit vehicle details. So you could have a nickname for the car. You can also add license plate things. You can add, you can change a number of different things. There's only a few, actually. So let me show you what I found last year. So you have some sort of context, and you'll see it's not hard at all. This is the same exact video that was sent over to Subaru as well last year. It's only a minute, so. So here's the handoff token here. If you guys can see that. It's a big arrow. It's a handoff token. It's just it's like an OAuth token. And this is in the cache database here. So what I did is I pulled this cache database from an iOS device, and now I'm using SQLite browser to view the contents of the SQLite database. And everything says blob, but usually whenever I see SQLite databases and it has blob, I just kind of click in the middle, see what I find. And it's it's binary data, but not really. You just send it to make it a text file, and you can see these are all the requests and responses that are cached. So literally copy and paste, a handoff token there. Boom, logged in. But wait, it gets better. Let me log out. And then try it again. Sweet. And even if you log out of obviously, if you log out of the phone as well or anything, it's always live. And it creates new tokens as well. So it's like, nested tokens, and they never expire. So I can imagine like their database, their session states. So what I did, well, we'll see. So that was, in short, that's the bug that basically got me. It was fixed last year. I talked about that a little bit at IoT Village last year. And it was fixed before I gave the talk. Somehow, they remerged their code and reintroduced it. Because that happens, I guess. Okay, so next step, I went through the web application. Again, same methodology-wise, proxied everything, except there's more options in the web application. You can change specific settings. You can get into more detail, changing a PIN, because there's certain, there's a PIN code that you are supposed to use to make these remote service calls every time, you go through the app or through the web application. You're supposed to put a 4-digit PIN, which could be 1111 or 0000, by the way. And you can change the password, security questions as well. And again, there's personal data. And similar, everything's all in Burp and the app as well. So from there, I had a good baseline from the AppSec point of view. Again, not from like the firmware aspect yet, although I did pull the firmware this week from my car. So stay tuned with that. So there's some roadblocks that I saw and some differences between the apps. I saw for anytime I was going to unlock the car or any remote service, there was a unique session ID in the post parameter, almost like a CSRF token, but I couldn't find where it was exactly coming from. It wasn't hard-coded in the mobile app. It wasn't coming from the server because I was proxying it. So I moved on, just noted that as something that was of an issue. And again, I was in fear of session expiration and randomization, but as we saw in the last video, they may not be an issue. And then there's these security questions and a PIN, like I just mentioned. They must be sent to make remote service calls on all the apps. And the remote service calls send emails to the owner, if they have it set up, but by default they do. But it's most, not all of the remote service calls. And same thing with the security questions and PIN. So here we go. Again, we talked about the authorized users who have full control. So here's, again, what's observed here. The owner does not get notified if users get added. And you can add as many users. You don't have a limit to how many users you can add, which is strange. Found a cross-site scripting in the vehicle name. So there, that's huge. Again, no anti-CSRF tokens for state-changing configurations like pins, security questions, names, and so forth. URL rewrite everywhere. So same thing as the last video. Everything's in the URL. Nothing's, not everything is being sent as a post body request. The mobile apps were, and we'll get to the web application as well. And again, the token never expires, ever. We talked about that. Even if you log out or change your password, which is funny. And then we talked about, there's no, there's new tokens that get issued when you have a new device as well and installed. So if I have 2 accounts and I have 3 devices, you'll have, 3 tokens for one account, 3 tokens for another account. That's 3 devices here. Each device has a token, and it's all tied to the same account. So I have in red up here, car hacking email 1 at the bottom. So in the red, you can see there's 3 different devices. I had an Android device and 2 iOS devices. And those are 2 tokens that were issued. You can do, again, more. You go through emulators. You can do whatever you want, really, and grab a token for that user. Let me take a step back so I can show you guys. This was a cross-site scripting vulnerability in the vehicle. It's a vanilla cross-site scripting, like literally no output encoding whatsoever. And I use that, obviously, as a foothold to get one of these tokens, because that, you have to have a valid session in order to make these calls to the user account, the MySubaru user account. So again, you can keep making these tokens here. They can go on forever. You can have 10 tokens for one user. Same thing with 10 users. And even you only have to get the owner's token. You can also get an authorized user's token and have the same access. So say I delegate, I assign, I don't know, my little sister an account, and her token gets compromised, and someone who has access to that token can also perform the same calls as me, as the owner. Here's some more vulnerabilities, of course. The web application sends everything as GET requests, even the remote service calls, without a session ID. The unique session ID I was talking about that I had an issue with for the mobile applications. So I checked that one off. I was like, cool, don't worry about that anymore. And the web application also didn't require a PIN or security questions to send these remote service calls. So again, weak link, obviously, the web application. And as you can see over here to the bottom right, you don't have to verify your PIN. You can just create a PIN and confirm it. And same thing with your security questions. So no validation, and definitely vulnerable to replay attacks. And there was no certificate pinning or cert validation. No cert pinning for iOS, but for Android there was, oddly enough. But you can still proxy the traffic because there wasn't any certificate validation. And no rate limiting. So you can keep sending these calls as long as the car is going to accept the calls. There is a tiny delay. It's like 5 seconds, but that's because it's going through AWS, coming back down. It's already making the call and processing it. So nothing crazy. So at this point, I'm like, yes, I have everything I need. I already have, I have XSS. I have a way to obtain a handoff token and CSRF. And I can just, craft a malicious page with the cross-site scripting payload to gain a valid session with the token. Then right there, add a user and make remote service calls via CSRF. Very, very simple. Sounds simple. You guys know what CSRF is? It's basically forging values from the My Subaru account. So in this case, it's the remote service calls. So unlock, you just send, literally it's over, it's a GET request. You just send with, a timing, and it's like either 0 delay or now. And all you have to do is plug in the handoff token, and your game, it's good. So obviously you can automate that. You can just send, HTML page if someone's logged in, and then from there, use the same methods, the cross-site scripting, obtain the token, or you can do it manually to add the users. All you really need is that token, to be honest. And again, you can track the owner and track where the car is at as well. So for example, right now, my car is in Los Angeles, and I'm over here. And if you press even this little maps, it gives you directions right to the car, like literally where the car is at. Like, I went earlier today, and I was like, wow, it's exactly my address. So it's pretty coarse. So here are some attack scenarios. We talked about utilizing the cross-site scripting. You can have the victim log in on the attacker's device. Hey, can you show me real quick? Can you unlock your car? Very, very simple. You can have the victim, oh, you want to charge your phone, and then from there trust it. Back up the content for Android and iOS, depending on what device they have. Because on their Android application, you can back up the application data as well. So, and again, all you need is the handoff token. So once you have that, it's fair game. So you can also just man in the middle. Again, they're very, very, very targeted. Anything within IoT, connected vehicles, anything like that is very targeted attacks. Even if you're on the corporate network and you're logging in with your Subaru account, you can look at the audit logs. They're all GET requests. If they're all proxy, they're not doing any cert validation. Some admin can use that as well. Pretty sad. And again, social engineering, again, to obtain a token, you can install a malicious application. I forgot to mention, they did log everything to console and to Logcat, so in console iOS and Logcat for Android. So you can easily grab that data, and you don't even have to, again, authenticate for the iOS device. You can plug it in and have console running to grab just the token. So it's very, very simple. If someone who has a My Subaru connected vehicle, to get that token, aside from cross-site scripting, more technical approach. So here's the auto login. This is the new application, actually. Literally, it has my credentials just pasted in there every time I open up the app. You just press login. So if someone logs in one time, on the attacker's phone, they can have it forever. So, once you have access, what can you do? Pretty obvious, the first one, you can steal the car contents, sabotage the vehicle's engine. It could be expensive. For my car, it could be expensive. You can retain persistence in the car, the car's account. You can implant an out-of-bound tracker if you wanted to. Wi-Fi pineapple with GSM, those things are fun as well. Some post exploitation stuff. You can also, like I said, there's no rate limiting. You can loop the car locking API calls and maybe have it for ransom. I don't know. You can drain the battery, definitely. That's something that you can do. If you're making these calls all day and night, your battery is going to drain at some point. There's not a way they're going to be able to stop it unless they call Subaru. And even at that, we'll talk about maybe some steps afterwards, what someone will do. But I guess the biggest issue here is it puts personal safety at risk, people at risk of, their content, not only their contents, but, something should happen to them, their safety as far as their privacy, their location. Those are definitely things to keep in mind here. And I mean, obviously, the list goes on as far as post-exploitation scenarios once you have access to a vehicle and their account. So let's talk about the likelihood and impact. Again, we talked about how many vehicles have My Subaru, connected remote services, but you have to purchase the plan. You get, I think, a few months free, and then you have to pay 99 US a year after that. And again, it's very targeted attack. And it could be wormable via the authorized users. Like I said, the tokens, all you need is one token from one user you authorize. And it could be a stranger's account, really. So likelihood right now is probably low, but the impact's pretty high. Although I did read this article last week, and it basically states that there have been no reports of any hackers or any criminals targeting self-driving vehicles or just vehicles in general, connected vehicles. So it got me thinking, like, well, are there any indicators of compromise? How is a user going to know? How is a manufacturer going to know? How are they going to let the service centers, the technicians know? Are they going to be qualified enough to make those decisions? I'm sure they're going to say it's an electrical problem. If their car is unlocking, they're probably going to replace the telematic system. And then, what's the escalation path as far as law enforcement and sharing that data with other car manufacturers? And, as far as their teams, how many of them have incident response teams that can go to, wherever an incident happened with the car being compromised? And how long would that take? And even us as professionals, how would we know? I mean, I don't know if I even know. There's only certain things that OBD2 logs, and they have a number of modes here. It's 10 modes, and they have other details, metadata basically, RPM, speed, temperature. I guess pretty detailed, but how are you going to log something you don't know what to look for? And especially in the telematics area. So, it's a question and a food for thought to think, in the future, how this is going to be handled and shared with other manufacturers as well. So I'm sure right now it's just in its infancy as far as connected vehicles and cars, and there's more to come. So let's kind of switch gears and talk about some manufacturer lessons. And usually when I do submit bugs to vendors and to a couple car manufacturers, Subaru being one of them, I always send them some extra references and some things they should try and implement, like a disclosure policy. It's pretty difficult to get a hold of them, but once I did, it was fairly simple. I pointed them to some best practices with NHTSA, and that's in the States, as well as Auto ISAC, which is basically where the auto manufacturers share data amongst each other, so if they're a part of the group or a member of the group. And there's also some guidance documents, observations, recommendations on connected vehicle security with Cloud Security Alliance. And there's a 5-star automotive safety program from I Am the Cavalry, which has some things like the disclosure policy as one of the steps, and incident response plans, things like that. Anybody heard of I Am the Cavalry? You guys? Okay, cool. And from, I guess, the coding standpoint, there's plenty of guidance, documents, cheat sheets, and especially from OWASP. You have, if you're building a new application or applications already existed, you can use the application security verification standard from OWASP. So it's basically a set of requirements and checks that an application should perform. And they have one for mobile as well. And then there's also the Embedded Application Security Project, which I lead, shameless plug. But I mean, there's best practices that they can all follow from all aspects of a connected vehicle. But definitely threat modeling is something that should happen. Like, please, threat model. And here's a basic threat model methodology. And it's kind of, how you would do it as an attacker or internal enterprise, identify all the assets, create an architecture diagram, decompose it, identify the threats, document the threats, and rate the threats. This goes for, again, every piece of software. And continuous testing, internal, external, even use third-party platforms to get more eyes, basically, on the code bases. And definitely observe and learn from other manufacturers' downfalls. So it's not all doom and gloom. They've actually improved as far as Subaru. They have some new, some little features that were added. One of them is your last sign-on. Okay, that's cool. At least I'll know, when someone signed on. And by the way, there's no concurrent login limit, or no, not even an alert. And I think in the context of a car, a vehicle, that's something that you might want to have. Just be aware of that someone else has logged into your vehicle's account. But they actually implemented output encoding. I'll show you guys right here. So obviously that's going to be my name. Everything's always script tag stuff for me to see if anything executes. They now have rate limiting in place. They don't send raw credentials over the wire. Everything's over posts now. And your account gets locked out. And now you have an option to deauthorize devices, and you can see how many devices are logged into your account. And so granted, it was a matter of 2 months when they put all these security controls in place. That's pretty cool from a manufacturer to do that from basically almost nothing. And now, some basic things, controls, and probably some logging on their side as well that can help, improve their security posture as a whole. So guys, any questions?